Every day, we use social media platforms such as Instagram and Facebook. At the same time, we rely on systems like university database to store student information. But have we ever stopped to think about how all this information is managed? In fact, all the systems operate based on fundamental concept in discrete mathematics known as relation. A relation describes the connection between elements of two or more sets. Although this concept may seem simple, it plays a crucial role in modern systems, especially in data management and social network. Therefore, in this video, we will discuss how relations are applied in database systems and social network, as well as their importance and limitation in real-world application.
At this point, let us move to the concept of relation. In mathematics, a relation is defined as a connection or relation between elements of two sets. It shows how one element in a set is linked to one or more elements in another set. For example, if we have a set A representing students and set B representing the courses, a relation can describe which student is enrolled in which course. This means one student is related to several courses, and one course may also be related to many students. Visually, this can be shown as arrows from set A to set B, where each arrow represents a relationship between the elements of the two sets. Relations are very important in modern systems because they help us organize and understand data. In database, school system, social media, and even online shopping platforms, relations are used to connect users, products, and information efficiently. As a result, relations help us understand how elements interact with one another within a system, making complex information easier to manage and analyze.
Now, let's move on to the topic of database relationship. A database relationship is a connection between two or more tables in a database. Relationships are important because in a real system, data is not stored in a single table, but is divided into multiple tables that are linked together. For example, we have three tables: student, course, and also enrollment. The student table stores the student information, the course table stores student course information, and the enrollment table connects student with the course that they take. To create this connection, we use primary keys and also foreign keys. A primary key uniquely identifies each record in a table, while a foreign key is a primary key from another table that is used for a relationship. In database, there are three main types of relationship, which is one-to-one relationship, one-to-many relationship, and also many-to-many relationship. The first type is the one-to-one relationship. This means that one record in a table is connected to only one record in another table. For example, a student and a material number. Each student has only one material number and each material number belongs to only one student. The second type is the one-to-many relationship. This happens when one record in a table is related to many records in another table. For example, one lecturer can teach many students, but each student is usually taught by one main lecturer for a particular class. So for the final type, which is the many-to-many relationship, this means one record can be related to many records. At the same time, those records related to many others. For example, students and courses. A student can take many courses, and a course can be taken by many students. To handle this type of relationship, we use an intermediate table such as the enrollment table to store the connection between students and courses. You must be wondering, what is the importance of relationship in a database? Database relationships are important because they help prevent data redundancy, which means avoiding repeated or duplicated data. They also help maintain data integrity, ensuring that the data remains accurate and consistent. In addition, relationships also allow queries to run faster and more accurately, especially when retrieving data from multiple tables.
When we think about social media, we often imagine likes, shares, and followers. But beneath all of that lies a fascinating mathematical structures. Using graph theory, we can explain how people are connected online. Each user becomes a node, and every relationship, whether it's a friendship, followers, or a professional link, becomes an edge. This simple idea allows us to map the invisible web of human interactions in the digital world. Now, not all connections are the same. 1. Friendship is a two-way relation. Think of Facebook. Both sides agree to connect, and information flows back and forth. Follower relations are one way. On Twitter or Instagram, A can follow B without B needing to follow back. This creates a directional edge, showing influence flowing in one direction. Then we have mutual professional connections. Like on LinkedIn, these two-way links are especially powerful because they can expand networks, open opportunities, and spread information across industries. By categorizing these relations, we begin to see how different platforms encourage different patterns of interactions. So why does this matter? Because relations are the key to social analysis. They help us answer questions like, who are the influencers, the nodes with the most connections capable of spreading information widely? Where are the communities, clusters of nodes tightly connected, often sharing common interests or identities? And how does information flow? Does it spread quickly through mutual friendship or does it travel further through one-way follower networks? These insights are not just academic, they are used in marketing to target audience, in politics to understand opinion leaders, and even in public health to track how information or misinformation spreads through society. For example, during a viral campaign, researchers can model how a single post travels across a network. Sometimes it spreads like a wildfire because the influencer has a large following. At other times, it remains confined within a small community. Graph theory helps us predict these outcomes by analyzing the structure of connections rather than just the content itself. So, in conclusion, relations on social media are far more than just friendships or followers. They are mathematical structures, nodes and edges that reveal patterns of influence, community, and also behavior. This is the true power of these structures. They allow us to take something as complex and dynamic as human society and represent them in clear logical patterns. By mapping these networks, we don't just understand how social media works, we understand ourselves, our communities, and the way ideas shape in a digital age. Thank you.
Relations are widely used in mathematics, data science, and real-world applications to model dependencies between variables. However, applying relations, especially at large scale, introduces several technical and practical challenges that must be addressed. Now, let us look through the limitations. One major challenge in applying relations is the inefficiency of naive recursion. For example, in Fibonacci sequence, the same values are recomputed repeatedly, leading to unnecessary processing as the input size increases. When applied to large datasets, this results in slow execution and high time complexity. As a consequence, systems that rely on naive recursion may experience long processing times and poor performance. Another limitation is the difficulty of finding closed-form solutions. Not all relations can be simplified into a direct mathematical formula. Many real-world relations are complex, nonlinear, or dependent on multiple variables, making closed-form expressions impossible or impractical. This forces systems to rely on iterative or numerical methods, which increases computational cost and implementation difficulty. So, to conclude, relations are powerful tools for modeling and analysis. However, their application comes with notable limitations: inefficient recursion, difficulty in deriving closed forms, and increasing system complexity, all impacting real-world implementation. Therefore, to overcome these challenges, careful system design and optimization techniques are essential.
In conclusion, a relation helps us understand the connection between elements from different sets. It plays an important role in organizing data and explaining how the components interact within a system. By using relation, complex information becomes more structured and easier to analyze, especially in modern technological systems. Therefore, understanding relation is essential as it forms the foundation many real-world applications we use every day.